Okay, so when you run an ANOVA, you get an F statistic. So just a little bit of background on the F statistic. And so this is coming from, this is on pages 391 through 394. Okay. So the idea behind F statistics, really, it's calculating a ratio. Okay, and what it looks at is it looks at the variability, which again is the spread of the scores within each group, and then it also compares the spread of those scores across all of those groups. So there's different values that are used in order to determine this. So you can calculate what's known as the total sum of squares, and the total sum of squares is the variability there is between the scores, right? So it takes each of the scores taken away from the grand mean, all right, and it tells us how much variability exists, how much total variability exists in this data set. You also can determine the model sum of squares, and it tells us how much of the total variation in the outcome is explained by the fact that the scores come from different groups. Okay, so we've got total variation, then we've got variation that comes from each of the groups, because remember, now we're looking at the differences across the groups. And then lastly, you've got your residual sum of squares, which is how much variation is not explained by the model, all right, because you are going to have variation in your scores. You're never going to measure perfectly, so how much error is there in those scores. Okay, so the theory of your F statistic, again, continued. It's calculating a variability that is explained by the model versus variability in the error. So if we have a large amount of variability on how the scores are spread as a result of, in this case, 3 different groups versus error, then ultimately we can say that there is a difference in the means, and then those differences are going to have an effect on whatever your dependent variable is. So when you have a large F value, you're in essence saying there is greater variability explained by the model than there is error. All right, so I'm going to go down here to this next slide. So here we've got total variance in the data. So we know that our scores are spread. We know we've got variability in this data. And is that variability explained by the fact that we have 3 different groups, or is that explained by just amount of error in the data? So if these 2 numbers were exactly the same, then you would say, well, your groups and the error that you have is the same, and you have an F value that is very small. But when we have variability of scores that are different because of different conditions, that number is usually going to be much larger than the error, and ultimately we find a significant difference in those groups.